Hi, this is Bob at airdensityonline.com. We're going to show you how to determine the high-speed bypass poppet pressure setting based upon the engine combination and the jetting that resides in there for a particular air density and combination. To start out, we're going to go to our baseline profiles mode, and what we're going to demonstrate is a combination for a 360 cubic inch engine, and it's at the horsepower peak, so that'll be with a high speed, and the air-to-fuel ratio is a little over 5:1. Again, that would be typical for a high output engine. The unique features of this engine at the horsepower peak would be a reduction in volumetric efficiency, which is the case as you go beyond the torque peak, and then the addition of a high-speed bypass to lean out the engine in an appropriate manner to maintain a reasonable air-to-fuel ratio. There are two RPM entries. One is an 8,000 RPM. That's a tuning RPM, and that is related to the fuel pump rating. That would be the engine RPM for the fuel pump rating. The second one is a target RPM entry, and this would be, for example, the engine speed entry that you would want coming out of a turn in this particular course, such as a short course. This can be changed to higher or lower values to evaluate the lower operating range in different engine combinations. In this case, we have it set at 5,500 RPM. What we're going to do now is examine one of four calculators. This one's the air-to-fuel ratio calculator. We're going to be assured that we have that combination selected. Since we only have one, that's our only choice, and that defaults to this setup. Now, this is the setup in the air-to-fuel ratio calculator for that 360 horsepower peak combination. If we get air-to-fuel ratio, this is a summary of the data that's significant for this combination. This is the uncorrected barometer, the density altitude for this combination, and again, air density at 95%, 30 grains of water. Our 8,000 RPM ratings are about 109 psi of pressure with the high speed open, a 5.18 air-to-fuel ratio, which is real good, again at 8,000 RPM. The target RPM values show, again, the same air-to-fuel ratio and fuel pressure, and this is what would be if the high speed was on all the time. What we're going to do is evaluate what the pressure would be without the high speed, that is, be the pressure going up to 5,500 RPM without the high speed. And to do that, we go into here and we remove the high speed entry. What this tells us then is that this fuel system without a high speed up to 5,500 RPM is at 90 psi. So if we want to open the high speed bypass poppet at 5,500 RPM, set the poppet to 90 psi, and then it'll open at that point. If the poppet was to be stuck shut, the engine would go really rich. In this case, 3.94 air-to-fuel ratio is what is shown. If we want to change the RPM to open the poppet, let's say we want to open the poppet at a lower RPM. Let's put in 5,000 RPM. That tells us to drop the pressure in the poppet to 74 psi, and now the poppet will open at 5,000 RPM. FYI, if we drop the target RPM to, say, 1,200 RPM, which would be an idle speed, this will tell us what the fuel pressure is available at 1,200 RPM. If we have a fuel pressure poppet, say at 8 or 9 or 10 psi, we're not even building enough fuel pressure potentially at full throttle at that from off idle launch. Thank you for your time.